All right. Are we? Yeah, thanks. Okay, I'm Marcus Nilsson, and I want to talk to you about reactive components with React. I'm a bit active on Twitter if you want to follow some nonsense about it. And basically that's where I get my own information as well regarding reactive programming, because it's quite new. Just heads up. The goal here is for you to start getting some questions in your head, not providing the answers, because it's too hard. I can either give you some philosophy or some code or a bit of both, but in like this time frame, the best thing for me to do is like make you curious, make you wonder, make you think. That's the only goal, not to provide one solution, but I will shove that single solution in your face anyhow at the end, so don't worry. Okay, the first question when someone looks at my code is basically, why didn't you just go with Redux? And I asked myself that question. So I have a quote here from their actual webpage, and where they list RxJS, basically reactive extensions, reactive library. And it's like, if you use reactive extensions, why are you even using Redux? Because it's so simple to re-implement the stuff that we're doing with whatever reactive extensions is. Let us know how it goes. But nobody is basically wondering. There's tons of reactive programming stuff doing what Redux does in what I think is a simpler manner and more powerful, but it doesn't get any coverage because it feels too like functional program-ish with all the monads and all the semigroups, group theory and whatnot. I didn't know that. I didn't know that it was hard. I just stumbled in the dark, like comparing two tools I never used before, and it's like, this seems simpler, and I went at that. And I actually think that it's not that hard. I also use React. I've tried SnubDOM. You can also use vanilla JS DOM, and if you go into the like functional programming world, people will point at vanilla JS, of course, because you're not a real programmer if you don't use the DOM. I would say the biggest competitor is Cycle.js, a framework. Because even though it's a framework, it's kind of like Redux. It's a small layer on top of something. It uses SnubDOM, I believe. You can change between RxJS as a library for reactive streams, or MostJS, which I will use today, which is really fast, or Xstream, which is a custom one for Cycle. You can also use Preact and Inferno instead of React, which is just kind of the same API but smaller. And I do believe that React loses when it comes to Preact and Inferno. I think React will lose. There's just too big of an API. Facebook is using the React API. Netflix is using the React API. They can't deprecate stuff anymore. So Preact Inferno using the same API as just something you plug in instead. That's something that I would change for my own projects in the future. But I think that React is a really good, stable mid-ground. And if you don't know what you're going to choose, just because I say, like, I will choose Preact in the future, I'm using React now and it works great. I think it's a great tool. It's a great fit. Going through this talk, we'll go into some philosophies. I will show some code in between, and then in the end, we will look at some source code and just discuss that. I will have some question points in the end. I know that you won't ask that many questions, so just think quietly, and if you want to share your questions, please do. But the first thing I want to make clear is we have a purpose here. And it's not about reactive programming at all. It's getting shit done. And all we do is CRUD. I mean, we have some entities in our web API, or we make a game. Whatever we do, we'll handle some kind of set of resources. Even if we work with flowers, We plant the flowers. We somehow look how they like, if they're doing well, and we like water them, and we maybe give them to the customer, and then they disappear or something. It's all about the CRUDs. And if we look at each letter here, creating code is really easy. You can use human generators or whatever. Like, creating code is pretty much solved. It's oversolved, I would say. But the reason that we focus so much on creating new code is because we have a small side effect called money. We can continue programming because we create new code that produces business value that someone pays for. This is the letter that we need to care about. The problem, though, is that we need to understand what we have created. And we need to understand legacy code that someone else wrote. Because if you don't understand that code, when will you have time to create new code? So the side effect disappears. You're just reading old code. And this is a really common frustration. And we don't have the tools really to, or tools isn't really like a library or something. We don't just put enough effort in reading code in a good manner. Same thing with updating. Like, this is the most common action. Like, once we understand the legacy code, we want to update it somehow, add new code to it that we create. But when it gets nested into each other, it's really hard to do. So like, this is a really common action. Where's the tooling? Where's our strategy for updating our code? And delete. Who wants to delete my old code? No one. You don't know what it does. You barely managed to read my old code so you can update it. How in the world are you supposed to say, like, nothing in this code base uses this small snippet? It's really hard, especially in JavaScript. So you just add more and more code, and that creates more code to read before you can update, before you can create code. So if you take anything from this talk, it has nothing to do with reactive code. Find your strategy for solving this problem. How do you refactor code? It's really important. So that was my goal, creating credible code. It was not to learn how to do reactive code. I don't care about it. I don't care if it's object-oriented or functional or whatever. If it's credible, I'm in. Oh. Think about that. And if you have any questions, share. Okay. And I'm destroying the red thin line through the talk by going to some history here about state and behavior, like how have we produced code before? And basically we have some kind of data structure. We have some kind of way of changing that data structure. Some state, some behavior. That's the only two things that we really care about. And if we look at this code here, it's kind of JavaScript. We set x to 5. We calculate the value, y, based on x. But when we change x, we need to recalculate y again. This isn't a problem that I hope we're having too much today. Nobody really does this unless it's maybe a bash script or something, but we shouldn't really do it there either. So we do something with like getters and setters, where we have some kind of backing value, and we get the price, and when we want to, we update the price with a set price method. And like, it's really not that different from before. But what happens when we create some kind of function closure outside the variable, we can hook into that logic. We now have a hook point where we can react to someone setting the price or getting the price. And in, I guess it was like early 2000 with Microsoft Silverlight, VPF and stuff like that, you had iNotify property change, where we somehow just kind of set on property change, said like, this stuff here, this property has updated. And we have some calculated property with no backing field, it's just calculated. And we say that, this is also updated now. And then you can have a getter, which is purely just a calculation. you don't need to update it because the update is kind of reactive. Kind of reactive because it's not some reactive framework or something. You just have an interface of how it should work. But you say which property changed and how it changed with some kind of event somehow. And if we look at today's future, it's not really that different. This is most, the library for reactive programming. You call something called async. This gives a subject back, and that's just weird words we don't need to care about much. But you can then call setPriceSubject.next. I forgot to add, of course, you have a price here you send in as data. So you send in event data, you call .next, and that's almost like a promise resolving, but you can do it over and over again. And you can have a discount stream here. I use underscore for notation for stream, because otherwise you need to write it all the time. Then you can just use .map, kind of like looping, but over time, asynchronous. And take the price, which you send in here by setting a variable price, and then you return half the price or something. Now you're totally reactive. If you somehow look at the discount stream, it will always give some value based on another stream. You're starting to combine streams together. And that's something to think about, like, what was new with that? What was old? What was different? Was it confusing? Why was it confusing? Like, this slide is really important to show, like, there's similarities. It's not that different. But there's something more, like if you compare this one with this one, you should find some truth of why it's more powerful. And for me, it's basically in I'm not using a framework's interface. Here, it's just a library. That means something. I can use it anywhere. I can use it in any domain. Okay. Really simple. If you have some kind of combination of streams, because a single stream chunk, that's easy. You just call .next or the function that wraps it, and then you observe the result. Bam. And there's really nothing. If you divide your code in the correct manner. Sorry, the question was how do you test it? It starts getting more advanced once you combine it. So don't combine it together. Then it's integration tests. If you want to unit test it, you need to keep them separate somehow and have some way of integrating them at a later point. So you always say, like, price is over here in one file. Discount price is over here in a different file. Then you can unit test them. And discount price doesn't need to know that it gets the correct price stream. It could get a price mock stream instead. So it's really simple to mock when you have a unison interface. So observables. If we look at writing our own custom observable, actually, I don't need to wait. I have it prepared if I manage. Here we go. Is the size good? I guess it is. If we have some kind of data source, which could be like a WebSocket, it could be an array, it could be just about anything. This is up to you. And that data source has some kind of event on data, on error, on complete. That will just call the same stuff on some observer. So the observer is keyword here. If we just look at how, so basically everything an observer is, it has the next function, it has some error, and some complete function. That's it. And you send the observer into an observable. So the observable can call your callback functions. This is basically like promises. You have a promise, you write .then, you add some kind of function, you can also write .catch, and you can get the errors. But promise only works for one time. Here you can do like, you can provide a callback for every single time you get a value. And a stream can also complete. You can even like get every single value, and after that you can get a promise back and do the complete and error as via the promise API. So it's basically promises, but you can get continuous values over time. And that's something that promises are lacking. And if you've seen some debate about cancelable promises and why people don't like it, it's because observable as an interface has already solved it. We already have the correct tools. We don't need cancelable promises. We already have them here. And we will see why later, why this is more good on like canceling stuff. So if I just, I could run here. Basically what this code does is just asynchronously print something out and then emit done. That's it. So really basic stuff, and it's not that powerful yet. If we look at a map operator, which is the other part, now we have observables, which you send in an observer to, which conforms to some kind of interface. If we look at map operators, and I hope most of you know about map, it's basically a looper. Let's see, that's the wrong one. No, it was the correct one. Anyhow, I think I might have screwed it up. Let's see, data source, safe observer. Here we go. Map operator. So you get some kind of source, some kind of map function, and you just map by getting like you get the original source, and you take that next value from the original source, you apply the map function and give it to the next stream that's like outgoing. So here we go, chaining stuff. It's kind of like a waterfall downwards. You get a 5, you map it to 5 times 2, and you get a new stream back. So it's like one source in, another stream out. And this is very imperative. Like this is how we would write it without observables. You need to some way hook up one value transforming to the next. But as we will see later, we will only use map as they were arrays. So we won't need to do this kind of messy code. And if we look at some kind of application of how this is done, we have some kind of library. And this is not my code. I borrowed it from the web page. We use most. Somehow we get an X input, Y input, somewhere where we display the result. So basically here, we write 12, 13, I get 25 back. Some kind of add function, convert the number, that's not really relevant. So the only thing here is like we have a from event, so we know like when does the input change. We already have the event via vanilla DOM.js. We just convert it to an observable, and that's really easy with from event and different converters. And then we make it to a number, same with Y. Then we somehow combine each stream to a new stream. You get the result, you then observe. This is what triggers it. So this observe is what kind of makes it tick. Without observe, no one is listening, and the trees won't fall. Like nothing will happen then. I mean, the inputs will still change, but the streams won't emit anything if you don't have any observer. So they're lazy, and it's pretty good for prestanda reasons to have it that way. So basic code doesn't say that much though. But you could just think about like, how would you do it without streams? How would I do it with Redux? I would have some events. You would have another event that are based on those events. Like, how do you calculate new events and do that in a good like descriptive workflow and not with lots of like imperative code? So the real power is really how you combine stuff. That's otherwise, if you don't need to combine, just go with events. Like add event listeners. You're done. You have that power already today. We don't have any issue. So we need to combine stuff, and then you start getting into like group theory stuff, and it's a bit scary. Lots of hard words and lots of smart people. We're smart too, but Lego and like cooking food and those kind of things are better analogies because it's less mathematic, easier to kind of grasp. So if we start just thinking about combining, like what's hard to combine, what's simple, what's complex, like if we take 2 + 1, what's the easiest solution here? Like think about it. For me and my girlfriend, we thought like the easiest answer to 2 + 1 is 21. Because you don't need to know math. You just take something that says 2 and 1 is like combine them, like combined. Bam! Done. But somehow we think that like 2 + 1 = 3 is the most obvious answer. Because we have some kind of strategy. We know how to crud our math. So we get a bit more powerful. We know how to work with it. And then when you start doing linear algebra and like matrix math, physics stuff, it's like, oh my God, that's so hard. It's like, look at like m = 2, 1. It's basically like the first one. We're back to like child level again on how we describe the combination. So you kind of need to get your head that just because you perceive something as hard to do, it won't be hard. Once you get the like knowledge that you're lacking today. Look at mathematics. Like the hardest mathematic solution here, like the matrix combination, is array for us as a programmer. That's easy stuff. We can also combine it like carrots and cookies, or like promise.all. And promise.all, that might be like, no problem. That's easy JavaScript for me if you've done like a bit of this before. But I know companies that like, that's dark magic. Like we don't use promises, we use callbacks. We don't need promises. That's like awful. It's so advanced. Oh my God. And like today, nobody wants to use some HTTP stuff without promise because it's too hard with callbacks. So you really need to keep this in mind when you learn a new thing. What is hard for real? Like, and if we look at combining stuff, when we do it with reactive programming, we have something new. We have time. We combine stuff over time. And that's the hard thing because it's new. It's not that complicated though. So if we look at this diagram, we have a merge of the first stream here, second stream here. So we have just some numbers which we don't do anything with. We just combine the dark lines here, where like the dark line is a timeline. So see that 20 here is emitted by the first stream. We get it in the merged stream as well. Same with 40. Whenever I choose to emit 40, we get the same result, but we don't combine the values, only the containers. And that's the simplest thing, and that's something that's really powerful. That's the most powerful and simple combiner in reactive programming. So this is the first one you should learn. Then you have something like combine latest, where we have a 1 from the first stream, an A. Notice that when we use combine latest to get a new stream, we don't get the 1 right away. It waits until it gets the first emission from both streams. Then we get a value. So now we're starting to kind of synchronize asynchronous events. Okay, so I want to fetch 2 states. but I want to show it as a one state for like on the view. Sure, just do toFetch and combine latest, no issue. And you choose how you combine. That's something that's up to you. You can combine it to some kind of object or a string or whatever, how you represent your state. And concat. So we can basically just say that we have a first stream and it ends in time over here. So you see if it ends later, what happens at the bottom? It adds the second stream, the result from the second stream, once the first ends. So we can say, take your time, do your thing. When you're done, I will listen to the other one. There's powerful variance here, because usually when you use web programming, we're interested in all kinds of events and nothing ends. If we have a router, we will kind of like want to show everything that happens on the screen I'm on the route I'm on. And with that completes, we want to show everything that happens on the next stream. The only difference here is that the second stream, when that comes into the picture, it will kind of shove the first stream out of the way. So there's kind of different solution of doing this, but you can merge two streams together without affecting the values. You can combine values and put that together into a new stream, or you can just like do it serially with streams. So we can combine values or streams or both in different ways. That's the tricky part, but it's not complex. Let's see. Let's go back. Is it confusing? Is it easy? It should be confusing. If it's not confusing, I don't think you get it. Because you've never done this before. Think of like if you never knew math or never knew how to read, and I'm showing you how to read or how to do math, you should be confused. So the confusing part is the time. You never thought about code over time in that kind of way. That's the question that you should start to think about, like, why do we even need that? Do I want that complexity? Don't I lose like the ability to just write simple code? Okay, so everything we've gone through right now is basically the goal. We just want to do credible code. You don't need reactive programming. You don't need anything I've shown you. We have already solved in different ways. We already solved like how we handle state and behavior in different ways. And the simplest way really is just don't handle it. Just change your values. Copy paste your code. You'll create shitloads of code. Nobody will understand it. People will need to update it all the time. And you will never be able to delete any code. But you solve the problem somehow. And looking at observables, we kind of shown that we can do one observable, describe how that thing exists from some kind of data source. So you wrap the data source, how it behaves in a stream. And from that point on, we can combine in different matters to different behaviors without introducing new state, which is like some variable getting a new value and someone else over here. So it's really, you get free isolation and you get really descriptive code because you're always dependent on what gets sent injected into your stream, and you always show like this is what I send out depending on what I get in. It's really declarative in that sense, even though I hate like imperative is bad, declarative is good. That's not true. But it's easier to reason about. It's easier for me to explain what my code does if I can write it reactive and have another reactive programmer read that code. It's easier to reason about. And think about it, like everything is a stream, even these slides. Like, oh, I don't have a question mark, but what will I do now? I've done this every time. And drink my water when you think about questions, or probably not, you just look at your phone or whatever you do. But you have some kind of event trigger, you do something, I do something. And now we combine that event of what you do and I do, that's totally different, and you start listening again. I don't care what you did. I only care about that we get kind of the same behavior together. So, time to code. And I hope that goes well. I won't be doing CSS, so I'm not worried for for the bottom one. Okay. I love that I got this as the first one, and I watched the entire show, Gossip Girl. Whoa, Gossip Girl! Yeah. Okay, so let's see here. If you want to get started with something like this, with React and reactive programming with most, or RxJS or Extreme, whatever library, I would say like do something simple like create React app, and it's basically all set up for you. And then you use React Storybook. You get that wonderful feeling of doing things incrementally, because otherwise you need to create like everything about Webpack. If you like watch any course on Pluralsight or something that does everything, you know, like setting up Webpack for 1 week before you start doing something. Don't go there, not for the first time. So create React app. There are alternatives as well. Let's see. No. Where did my code go? Here we go. So React Storybook. Basically, I can do the same component over and over again. And if this was Redux, and I have some buttons, and I click on this button, and I want to have like some kind of, I don't want them to be able to mash the button. So like for a half second, they can't press it again. Imagine how you would handle that state. That small extra thing, like how would you propose that to your team? Adding a bit of UX quality. So here we have state inside the button. I don't have anything outside that component. I also don't have any real styling, but I'm getting there. So basically, I can mash it. I will just get one press and then unpress back. I can compose to different kind of components upwards in a fractal manner. Check up fractal and what that really means, because if you have an API for components, you want to be able to compose streams and components, whatever component is for you. And when you combine it together, you should have the same API. If you add stuff like, no, now it's like a bigger component, now it works, like, now it's stateful, now it's stateless. Like, it's not, you have a stateful component, you have a stateless component. They're totally different. Like, you need to solve something elsewhere when you have a pure component, and you just like leak the abstraction upwards to the stateful component. And that's really messy. I mean, you need to read 2 components or more to understand. So, and another cool thing here is I can press this button, and this button is different streams. If I write something here and I press escape, it disappeared. Same action. So basically I've taken a symbol component here. It's totally isolated with state and behavior. I have another button next to it. It doesn't react when I click the first button because it's a different instance. It's totally contained. I can also extend the behavior upwards. I can still add new producers of events. The escape button, or write something, enter, write something, bam. Really simple. And what would happen if I delete the state from the button? It's totally contained. Nothing would happen outside the button because no one else needs to know that there's no state anymore outside of the button. The input field doesn't care. It only takes care of itself. And of course you can do it on high levels, and here we see the form. So the representation of the form is basically just based on the children beneath it. So it's kind of, we're getting abstract here with what is a component, because I don't have any styling that's explicit for the form. It's just based on the children. So a component for me is basically state and behavior, just with the getters and setters and all that stuff. I don't care about React. I don't care about reactive programming or anything. It's just getters and setters. That's a component for me. Something that isolates and functions and solves one thing, and you can extend it when you combine it in a fractal manner upwards. So, looking at some code, let's look at the button here. This could be an entire different talk, but notice this. All the imports here, and I have different kind of files, but index is the only one with imports. That's so I can do dependency injection when I unit test. This is not a unit. The component is an integration of different units that's together solves. When you integrate the parts, it solves one thing as a bigger integrated unit. And it forms an interface. And that interface should conform when you combine different components upwards. And the only thing that I handle here is, let's skip labels. That's basically just like tags, whatever metadata you want to add for some reason, whatever reason, it's not needed. We have some kind of action creators if you do Redux. You have some kind of state stream that you can observe whenever the state changes. If we look at the actions, this is it. This is the only code. I don't need any switch case. I combine. Forget about it. Why would you switch case? Why do you have those big units? Then you need to break them apart in different ways. I would need to use filter. And you will see RxJS people using Redux solution and filtering to get the small units back, because they lost information about where did the information come from. Which instance did I click on? You don't know that anymore, so you need to send some ID and filter and do some weird stuff. Start with the smallest unit. Notice here, it's hard to test when you have time. If you do something, it takes 500 milliseconds, you need to add something called a scheduler. So you can have a virtual scheduler so you can do better testing. Screw it. As long as you can, just inject how long it takes and put it to 1 millisecond or whatever. So if you test that it takes 1 millisecond more, but you don't need to learn about schedulers, go with it until it becomes a problem. And by then you're so advanced and good at observables that a virtual scheduler is not a problem. But for now, basically, I have a press stream. A subject is both something that you can call and it can emit some data. It has both ends. An observable only emits. So here, press subject, whenever I get a next, I delay it with like 500 milliseconds. And when that happens, when I press and the time passes, this one here will emit. And this is like this is an interface of how the button behaves. This is the entire file you need to look at to know how it behaves, how you can interact with it. It doesn't say anything about the state, the representation of the state, but it tells you about the behavior and how you can interact. So triggers is basically the only way for the user, the end user, to go in. And as you see here, 2 streams, but only 1 trigger, because you can only press. The user cannot unpress by its own. So you specify really like, this is what you can do and interact, but we have more behaviors that are internal for us, that are basically calculated events. It's not calculated values, calculated events, combined events. And if we look at index, we just create all the actions, we get actions back, we put the actions into our state together with object assign, but via Lambda. Send that in here. And we have some kind of initial state, always needed. No matter if you do Redux, React, or anything, always some initial states. We use some kind of reducer. It's called scan when you reduce over time. You send in the initial state. You get the previous state and some kind of reducer. You call that and return the new state. So this here is the most complex code when you do reactive programming. That's the reducer, because you need to work with closures in a funny way, but it's not that much code. And once you get used to it, this thing here where you return, map calls a function which returns a function. I won't go into it here, but it's a really common pattern. And it's easy to learn once you start getting like, you're back into it and just iterating over it a bit of time because you need to think about it. But afterwards, we have a state stream where we can do observe, or for each is an alias, where we can get the initial state and then each new state. And if we want to know when something breaks, we can use then or catch or something like that afterwards. Okay, so now it's state, but where's React? React has nothing to do with this. And this is important. Like, you should be able to talk to the user experience people and say, like, how should it behave? Do that model. Do a two-string thing, like JSON with some kind of console interaction. Then you inject the model, component model, which was the state and behavior stuff, or state and actions. Inject it here, and you see here, object assign. You just increase the API a bit with something that is viewable, and that's something with a view. When we send in React, I use styled components. Check it out, it's awesome. Some kind of helper. This isn't hard to test. There's a bunch of like variants for the colors and all that stuff, but here's the trigger. It's just an on-click handler. And then you do some kind of connect, and that basically looks like this here. I'm not done with that code yet, but component did mount, maybe some other lifetime hook cycle would be better. When the state changes, subscribe, you set the state. Every time the state changes, you call this set state. Component will unmount, unsubscribe. Nobody up the hierarchy cares when you update your state. React takes care of everything. So now we made a bridge from our component, totally self-contained. We don't produce any state upwards. We just send state to this .set state, and we're done. We can create our parent thing, and I think I'm basically out of time, so I'll just show quickly here. Input. I just send in my own behavior, and I don't have any other state. And OK behavior, cancel behavior, that's the button behavior. So I can show my own state based on those. I can react to the lower components. But I don't care about the button state, only the behaviors. So I can make my own reactions and update my own states. And if the buttons become some other component, I don't care. As long as I get a cancel behavior and an update behavior, I'm good to go. I don't care about buttons. So I hope that I've shown you somehow that we can kind of read the code and not care about the rest of the code. if you know reactive programming and just look at this file, you have no idea like of the context, but you can still read it though. It's kind of like a microservice. You don't care about like, does it use snubdom or React to do this? Like, you don't care. You send in everything you need and everything goes out. If you look at tests, I won't go through them, but it's basically really simple tests. That's the integration tests for the components. Oh, need to update that. But basically, you just mock it by calling another async, and then you can fake the behavior. And here we can fake unpress, so we don't need to wait 500 milliseconds again. So it's really decoupled, it's easy to read, with the price that is always harder to understand the big picture. So that's why Storybook is really important. You need to get some kind of feeling like what does the view look like to get some kind of overview. If you need to look at the entire application, right now it's just like this. But once you start adding more, it gets more complex. You need some kind of registry to see how it works. The last thing, one last window. So Redux has its own state tree. We can do the same like with state tree, but with cooler. We can activate any kind of action because the components are composed together as plain old JavaScript objects. So I can go to my router, handwritten like 50 lines of code with reactive programming. Do some action and change the route. You see up there, landing, some kind of outgoing side effects. And I can change back, log in. And also, like, if I don't have anything, it goes to login still. That's also a component. The router is also a component. The pages are also components. That's it. All right. So, source code here. We have a bunch of resources. I would say that most important is to follow the right people. Andres Stahls for philosophy, Ben Lesh for real examples, basic examples. Pluralsight had a good course that Jocke tipped me about. Check it out.
What's the name of the course?
The search for RxJS. Yeah. It was too long of a link for me to add. RxJS. And that's a library for it. Egghead.io for the specific questions. They will go through each operator and how it really works under the hood. Cycle.js, also philosophy and seeing how you do it in a framework way. So you can get a lot of inspiration from there. ReactiveX, philosophy 2, Paul Depin, his code is really good. If you do functional programming and want to do reactive programming with functional, I do it more object-oriented. And here's some more resources that's more like the nitty-gritty stuff. Yeah, so that's it. Thank you. Do you have time for questions?
Yeah, sure, of course.
Yeah, but that's good. Frowning faces is what I was going for, because, as I said, this is advanced, but it's not hard. It's not. If you just like saw every code file, you don't get that messy in the code, and it composes upwards, so it doesn't get messier just because you get higher up in the component composition. Cool.
So I have a question. Maybe this is obvious for the other people, but where do you start if you?
Most people start with Cycle.js as a framework. Yeah, everything with React it's basically like roll your own, and that's scary. So you need to start with hobby projects, and I think that's the weak point. Like everyone showing examples, they start doing arrays, and from the array data transform those things in different ways. It's not useful. So that's why I'm trying to hold some kind of talk, like showing like this is where you can start. You can start building simple components that work with React. And I do believe that if you check at the source code here and just like the button thing, that's the easiest way, because you need to start learning what operators to use and some basic patterns for like state. You will get into problems. Use Gitter, like Gitter or whatever chat program, but don't skip the chats. Don't go with only blogs and stay offline like from the rest of the community. Use the community. It's awesome. The only way that I produced this code is like 1 year with some terrific people helping strangers. Without the community, you will fail. So the chat is the most important, I would say. Yeah.
Okay, thank you.
Thank you.